Okay, that should be good. Yeah. Mm, can I reduce just? Yeah, that's good. All right. Um. Hmm. So let's quickly start with CST. Let's go to USAPO guide. It's under platinum. And what about alias trick? So I was reading about like the aliens trick, but I think it's good to first know what is CST and how it works. Then we can go and learn. Hi Rohit, what is up bro? काफी टाइम हो गया यार स्ट्रीम किए. It's been like almost a month, I believe. और honestly मैंने DSA भी कुछ करा नहीं है खास. I kinda I don't know, मेरा मन ही नहीं हुआ. Exams भी थे and all. I think it's time to continue. और मैं बोर भी हो गया था. Prerequisites are, so I should know what is convex hull. I already know what is convex hull. It is basically the surface, sort of a rubber band that contains all points. So this is like a convex hull. Convex hull using DNC. So like all these DP optimizations, advanced DP optimizations, they are all related. College exam, हाँ. 13 को था मेरा last exam. तो okay, so I already know what is convex hull. Fine. Geometry primitives. This is basic maths, right? What is this? Means that P1, P are collinear. Otherwise, the value sign indicates if P is under negative or positive. So there is a line, there is this point. Collinear matlab lies on the line. Wait, what? What is this? So we have 3 points. If this minus this, and to this minus this. Oh, collinear points. Collinear points that lie on a same straight line. Okay, these 3 points are cool. So what is going to be like common? First of all, if we try to find like area of triangle, we will get 0. That is the first thing. How are they doing it? So we have distance into distance minus demonstration. Yeah, slope should be equal. So rise over run equals to rise over run. Oh, this is how they got this. Okay, makes sense. We can also check for area of a triangle. That's also possible. Should be 0. Slopes must also be equal. If this point is here, then their slope will not be equal. Makes sense. Then we have this convex hull. We can find this in login. So it depends on the angle, right? So if we're starting from here and going this way, then that like the slope should be positive. Yeah, kinda aware. Consider a set of functions on some range L to R such that any two functions exist some M. So this is some range. So okay, let's draw. Yeah. So we have some random function in this range L to R. Okay. So for this till L greater, and for all this f of x is greater than with what? So यहाँ पे j greater है, यहाँ पे I greater है. Answer the query in a form. What is the maximum and minimum fx? So let's take some middle point m. Set of functions. Okay. So initially j is bigger and then I is bigger. So we could have something like this. Whatever. This is j is bigger, and from here I is bigger, right? This is I, this is j. Maximum and minimum for some given points. No two functions intersect at more than one point. Okay, this should only be one intersection point. What is this thing? What do you mean single intersection points? This can only happen if these two are straight lines. Oh, that is convex hull. Okay. So we're talking about lines. This is a equation of a straight line given two lines such that slope is greater, their intersection point is this. So we can get this solving this equation, right? Taking these two same, because x and y values are going to same. Then it is clear that. Okay, so they were talking about some like straight lines, I believe. So M is nothing but an intersection point. And yeah, I was bigger. Now J is bigger. क्वेश्चन कैसे होते हैं इस टॉपिक के? क्वेश्चन होते हैं डीपी, बेसिकली डायनेमिक प्रोग्रामिंग क्वेश्चंस, जिनमें यू हैव टू ऑप्टिमाइज बेसिकली कन्वर्टिंग n स्क्वायर टू n log n टाइप थिंग. लीड कोड पे आया था, देयर इज अ प्रॉब्लम. This problem here, this requires like these concepts, right? This problem requires even like advanced concept. This one, Lagrangian relaxation. But like it's not something that is new to me, because I have already studied about these things in my college syllabus. So this is basically should be in optimization techniques. There we go. Optimization algorithms for solving constraint optimization problem. Penalty function method. It is very similar to this. But like Lagrangian relaxation itself is a very good technique. It gives you like a alternative perspective to write a function in terms of its slope. So it's also called Lagrangian duality. You can check it out. It's I mean, first you like differentiate ML का topic. ML का topic नहीं है, it's a optimization technique basically. These all topics comes under like optimization techniques in maths. But हाँ, like ML में आते हैं. ML में you do use these sort of techniques. So okay. So we could also have like this, right? Wait. Yeah, that is also possible. Since we ignore access file term when comparing two functions. Special case of CHT where slopes of functions are monotonic. This specific case is solvable in O of n using a standard DQ in C++. For more general, which involves a multiset. Oh, so this is like a in advanced section. And this is incomplete. Let's first check this one out. Okay. Wait. It's a good article, no? ML भी आता है. हाँ, I mean आती है, but I don't do it anymore. Because I'm not sure about the feature of ML. Either I should do like go and do some research, but apart from it, like for a normal average person, ML is not going to do anything because all the basic things are done using LLMs now. Okay, so this is a convex hull. So, but how do we store this? So there are some intersection points and we have to store like before this point onwards, this is the equation, right? After this point, this is the equation. Before this point, this is the equation. And then we can use binary search to find like a specific equation that we need the answer from. So we have some sort of a DP formulation plus max of, okay, so f of I, we need to find like maximum of all from, hi Noor, from 1 to I. This I believe is a equation of straight line. So we have negative slope and slope is going to be what? Slope is going to be like this one, negative yi, because this x is changing. Wait, am I right? I think I'm wrong. What is going to be the slope of this particular line? So this is a slope, okay, negative y of I. But this is not a slope, this is a slope, right? What is constant? So f of j is constant here, right? Because j is like 1, j is less than I. So we must already have calculated it. So now it's constant for all the values after j, right? And this is a slope. Okay, and we have to query over y of I. So we need to have like slope and this thing, and we also need to know like these points, these specific points. So we should have a dq. So this is some different problem related to rectangles. Yeah, so we have this line I and j, or this return slope only. It's just like a slope formulation. Yeah, so we have a dq, but they only have a single element inside a dq. The problem is different. Okay. All right. So like in a standard form, we first need the coordinates so that we know like till which point this equation is valid. And then we need the line. So in a dq, I have to store integer, which will be x, or maybe like a double value. And so it is going to be a pair. The another element is going to be a line. Let's do it. Let's create okay. Let's go with the structure. Okay, so let's create its name as line. Now our line have a slope and it also have an intercept. And these two things can uniquely define a line. Let's create a constructor. So when I create a line, I will give like both of these things, right? Yeah. So are they going to be like, let's define long double just to be safe. Let's make it like LD. So okay, so we have a slope and we have intercept. Oh my god. Okay. How do I initialize width? So slope equals to what? And wait, C++ structure initialization. There is a easy way. I can use a column. Oh, column. Okay. Oh, something like this. So this X is basically a. So we have a slope and an intercept. Do I need anything else? Maybe not. Let's also create a structure for hull. Let's call this hull. And yeah. So this hull is going to have a line. Right? Well, this hull is going to have like a lot of lines, not a single line. And we need to write like function to insert a line and remove a line. So so what do I want to have here? I maybe just need a queue. Or maybe a DQ. So this will contain pair of our value LD and line. Okay. That is fine. Let's call this DQ only. How will I initialize this? I believe nothing. I can just go ahead and write an insert function. So inserting a line means having slope and intercept, both of them. So let's talk about insertion. First of all, slope should be monotonic, because in this specific problem, this is a slope. And if we talk about x of j, then x of j keeps on increasing. And it is negative, so slope is decreasing. And we are finding maximum. So slopes are decreasing means something like this. Now this is a hull. Right now, if we get something like this, I'm not gonna insert it in that scenario. So that depends on intersection point. Okay. So intersection point should be either equal to or before. So equal to is also fine, because slope is less, then we are going to have a better answer here. Better convex. Yeah. Not able to see code. Wait. Okay. Okay. Let me do this. Okay, this is better. And also this. Now it will be easier to see the code. Right. Okay. Okay, so this is a line. But like, am I assuming like slopes are always monotonic? That depends on the problem. Let's write this code for minimum, and in minimum, we are assuming like the slopes are decreasing. This is decreasing slope, right? Rise over run. So what is happening? Rise over run, right? What is the difference between these two? Where slope is bigger? So slope is bigger here, right? Exactly. It's decreasing basically. Okay. So we are assuming like slopes are decreasing. So I'm not gonna check it. I need an initial value and an initial line as well. So let's quickly create a constructor for hull. Okay. And so empty, and I'm going to dq.push. And I'm going to push. So this LD is basically going to be, so I'm also considering like everything is starting from 0. So X is starting from 0 maybe. So I can push 0. What's the issue with pushback? Okay, so we also need a line. So let's quickly, what will be the slope? So let's take this line. Okay, what is the slope? Slope is like infinite or something. So let's take long max. We can assume like slope is, values are not greater than 10 to the power 18. And intercept we can take as 0, right? So we can take like line here. What's the issue? डिजिट डीपी के क्वेश्चन करे जो कि मोस्टली हार्ड मार्क्ड होते हैं लीड कोड पे, दे आर इजी. डिजिट डीपी इज इंडीड इजी. लीड कोड हार्ड्स के भी अपने लेवल हैं. Some problems are just very easy. They don't even deserve like a hard tag. But also it's like about whether you know the topic or not. So I believe digit DP is not something that people know, most of them. So this is why it's termed as hard. I would say even convex hull is not hard if you know like basic maths. Right? These things are not hard. But see, if the question comes up and you know the trick, you can solve it. What's the issue with DQ though? No instance of overloaded function matches the argument long double. Is this because this thing? I don't know. Why is this happening? I mean, some type issues. Push back with. So if I change this to like, let's say integer. I think issue is with not the data type. There is some other issue. And I don't know what's the issue. By the way, do I even need like a DQ? I can use a vector. Right? That is fine. I don't understand the issue with this. Do I have? Not here though. Let me open in a new tab. Let me also paste the issue. I don't want to see any code for this. But this gives me a pointer, no? So each element must be pair. But I'm pushing this thing. This is the issue. If line is an abstract class, the first option won't work. So this is creating a pointer. Now this should be fine. Okay. So while inserting, what we are going to do? Can I just make my life easier a bit? Okay. Yeah. Okay, so how do we insert? So this line comes up. We need to find the intersection point. Okay. So intersection point is just m1x plus c1 and by is m2x plus c2. We can subtract both, so this will be 0. We will have x common, m1 minus m2, right? And we will also have like c1 plus c2, right? We can do this. we can send them here. So we have like C2 minus C1. So we have this C2 minus C1 upon M1 minus M2. So this is going to give me like the X, and this is exactly what I want, right? So X is basically C2 minus C1. So what I'm assuming, what is C2? C2 is coming from, let me also take the stuff from the line, from the V. So what should I name it? It's called 8. So this is basically V dot back. Okay, we have this stuff, and the point of intersection is basically V dot I, V dot second. This is going to give me a line. Okay, now inside a line, so this is not a pointer I can directly access. Intercept, I can minus this intercept here, and I can divide it by slope minus a dot second dot slope. Fine. So now we have an intersection point. Should I use A for while? So we could have like a hull like this. Let's say these are the lines. Okay, so something like this. Okay, so after this line exists, so I only need to compare to this line. Okay, so we got X is greater, so this has to be here, right? Okay, so we have this stuff. Wait, what I'm thinking? Am I thinking something? If another line comes up and it looks something like this, then I have to remove both of them. But in what basis? Until this X is less than or equal to while loop. So while X is less than or equal to B dot back. Wait a minute, this is not right. So first I will check with this line over here. Then I will do a check. Okay. So this is absolutely bullshit. But then how will I? Yeah, now it looks good. Okay. So here we have to how do I frame this? Okay. Okay, so if if x is less than or equals to b dot back dot first. Okay, then we will just do like pop back. Okay, because that becomes useless now. We will keep doing that, and after all of that, but what if that is not the case? We can return, no? We don't have to insert it. Else we will push back this thing over here. So what we're gonna push back? What if there is nothing here? The zero line will always be, so we have zero intersection, right? This cannot be greater. So so we have this line over here. Okay, anything going to have like greater intersection, so we can insert anything, no? If not empty, right? And this x is greater, then just return. Okay, if that is not the case, then we need to push back the intersection. But what is the intersection? This is what I'm thinking. Do I need to like keep inserting? Maybe not. Well, I also have to see like slope minus this thing. This should not be equal. If slopes are equal, I will be. Okay, let's see. Let's see. This should be something. Should be something. Should be something. Not of v dot empty. I'm looking at what is like here, the back. But is there any case where this could be removed? There is no case. This will always be greater than 0, right? Which is the line that can actually have greater slope? There is no way. There's only one scenario when the line is parallel. That's not going to be the case. Okay, this is completely fine. This is completely okay. But I need to be careful about the slope. If the slope is same, that means lines are parallel. So there will be no intersection between them. Then why am I even... But I know like slopes are increasing, so this is not going to be equal, right? Or they can be equal. Well, in that case, this line is completely useless, right? So that is the only case I'm going to insert. Right. What am I doing? What the fuck? How do we cut? Okay. It's fucked up. Control X. So I'm gonna push X, and then I'm gonna push new line with this slope and intercept. Okay, so I think we are good. This looks very fine to me. We need to write another thing, and it is going to be LD. This will be query. Okay, I will be using binary search for this. So inside this query, we are going to have a right. So what do we do here? We will find a X that is less than or equal to, right? So I can start with upper bound. So it's going to be give me like greater than. Okay, something like this. And upper bound over v dot begin, v dot end is X. Do we actually need a constructor? I believe so. So we're going to have this stuff here. What do we need? We want this particular value. Basically dot first value. How does the constructor of upper bound looks like? I'm not sure about that. We just care about a dot first. Wait, I don't know. Wait a minute. Let me ask GPT. How do we do this? How to do this? Okay, so we can take like these values. So we can take X inside, and then we are going to have a pair. So we are going to have this X here, and then we will have right. So I'm just taking reference. So what do I want? I believe that is correct, right? P dot first greater than X. Wait, what does that mean? What do you mean by this? Let me wait. So if that is the case, so the first time you find, okay, so this is binary search. So true means moving right or moving left. This is what I'm not sure of. Upper bound, it wants first element whose key is greater than X. Fine. When comparing the search value X with element P, compare X against P first. Okay, so if What is true condition is comparator. Comp value element. Okay. 7 is greater than 5. That is true. So it is going to find the first element where this stuff is true. Now that makes sense. And we are going back. Okay. So we are at some element. Okay. So if we have some sort of a hull here, something like this, we're finding something greater and then we are coming back. So at this particular index, let's take it as okay. So we have a particular value. We have x. What if it's equal? Well, if it's equal, then both work, right? Either this or either that, because both are going to give the same answer. So this is fine. Anything else I can do? I don't think there is any edge case. So all I need is to return the answer. Okay. I mean, I should probably get the line. So that is going to be like p dots. Wait, we don't have values here, do we? I mean, now we do. Okay. So we have the line now. And the value is going to be x into line dot s slope plus line dot intercept, and we are good. So both things are sorted. I think there might be some mistake here. I'm just not sure about that. So like that is it. Let's solve this problem. Yeah. This is a 2400 rated problem. Really? So this is not like a I have never even solved like 200. ये हुई ना बात. हाँ जी, फाइनली मैंने सोचा कर ही लेते हैं. फेवरेट कोडर. ओके. Easy. Yep. Okay. These are vertices. We have 3 integers, so we have x, y, and a. Consistency, बिल्कुल बिल्कुल. कर लिया करूँगा. Yep. Sure. AI, choose some of them that the area of union minus sum of AI of chosen one is maximum. So we want to maximize area minus AI, something like that. Okay. We don't need this function, neither this. So we have this n. Now okay, we have these 3 points. How should I store them? Let's first frame this problem into like convex hull. Let's look at the recurrence. So some rectangles are given. This is just like a constant, sort of a cost that we need to reduce. So 0, 0, 4, 4. So height is, so we have like height and we have length and width. So what will be like the area of union? So if there is like a big triangle, so that is going to be like the biggest x1 and biggest y1, I believe, right? So if I like combine all these three, I will have like 5 height and 5 width, right? And the area is going to be 25 minus 18. So I will have like 25 minus 18 is like 15 minus 8, 7. The answer is 9. So I believe we might have taken like these two because we have the same area, that is 25, but now we have only 10 cost. Not really. Okay. It is guaranteed that there are no nested triangles. What does that mean? Area of union. In a first example, the right can be achieved by choosing first and second rectangles. So 5 4s are 20 minus 8. I might be wrong. For each rectangle, you are also given a number. Choose some of them such that the area of union. What the fuck is that? I mean, we have some rectangles, okay? Could be like any fucking shape, doesn't matter. But what about like union area? So if I take all three, this is going to be the union, right? So it is basically maximum height and maximum width. That doesn't seems to be the case though. What does this mean? No nested triangle. We are given this stuff. What should I do? Let me ask GPT. What does this mean? Okay. No. All have one corner, but they can have like different width and heights. So if you choose several rectangles, union is not um wait a minute. They can have different widths and heights. Right. Yeah. So this is like rectangle I 0 to x1 into 0 to y1. So if we choose several rectangles with maximum x, maybe different. Yeah, that is true. So tan comma 1 and 1 comma tan looks something like this. What the fuck is this? The fuck? So area is tan into 1 plus tan into 1 minus 1 into 1. So this... Okay, I got it. I got it. I don't need your help with anything else, which is much larger. Union is not full. So let's talk about this. Okay, so we have 4 comma 4. So that is like the first rectangle. Then we have 1 comma 5. Let's call it like this is another rectangle that we have. So which is choosing like these two, we are going to have this whole thing. So what is 17 minus 8? Exactly 9. Okay, that makes sense. But like, how do we... we can remove common and then we can do it. So there is this rectangle 4 comma 4. So this is like overlapping. Makes sense. If it is overlapping, it all depends on this particular thing. How do I get this? How can I get this union? I can find for everything, then I can maybe reduce. I can reduce the common. I can see like what is common. So yeah, this is a way like I can take at both of these areas, then I can see like that is going to be an issue. What if we have more than two? So if both are less, then reject. If both are greater, then make area 0, add this new one. But if there is something like this where one overshoots and other one doesn't, right? In that case, just look at the difference. Okay, just look at the difference and go with this term. I mean, that is doable, but So the question is hard because of the framing, not anything else. Well, right. This is how we do it now. So we have to maximize this. This is the whole area, but so this must be some. What is x of j? That is some other values. Yep. X coordinate. That is some other values y. How does this help? What is f of j? F of j is like maximum possible. So we know like union is this. Okay. If like till j that is the union, that means how is this working? Like subtracting xj of with yi. So that basically means if I have something like this, let's say this is 5 5, this has to be 6 1. So it's like say it's like, so here area is 25, right? But now what you're doing, you're saying like 6, you can do 6 minus something. You're doing like 6 minus 5 into, I don't know, I don't understand this. How will I get common? Let's think about this. Common is just like minimum, so maybe we can reduce minimum. So once we know this is 6, we can take like common, so it's going to be 1 into what is common, 6 or 5. 5 is common, then we can get like 1, and then we can add 1. So we need like minimum of, but I don't know what's going on here. um, Wait a minute. If you sort rectangles by X, then after removing dominated triangles, pi becomes decreasing. Okay, so it's wait, what to and after removing dominated rectangles. So if X is greater then and Y is also greater, then that's a dominated rectangle. So we can only have like X greater, Y should be lesser, else we can pop. What does this mean? I don't get it. Also, ChatGPT is like stupid. Suppose we sort by X. Okay, consider two rectangles. So J is greater, X of J is also greater. When is rectangle I useless? When it is smaller, like both. Yep, that makes sense. That also makes sense, but how does it? Properties what makes TP work nicely after pre-processing. So we have to do this bullshit. We have to maximize it, maximize the area. And A is always greater, so if something is useless, we can always remove it. I see. Okay, then what you do, like this is the area, and then you will try to reduce like the extra part. Okay, so we have rectangles something like this, I believe. Right, so you take this whole area, then you try to subtract this one. So what is this one? This one is by into X of this. Now that makes sense. Okay, fine. Okay, now we can do like convex hull here. But why are we removing rectangles? We are reducing A. We are subtracting. AI. such that the area of union minus sum of, so we need to reduce this, so it's not like straightforward. Because we also have to see there is no nested rectangles, so there is no case. Okay, so there is nothing like this. Okay, now that makes sense. I don't have to think about it. Okay, so because of that, okay, what am I doing? Okay, now let's quickly, I hope I can insert like this. Yeah, no issue. Okay, what? Okay, now we have these things. Let's quickly sort this one out with X. So this is X, right? Now let's talk about like optimal answer. So we can decide to choose like any of them. Okay, so let's define dp of I. It is like the maximum possible, let's call it score, like score by choosing some subset of rectangles till I. Okay, and now for every I we have to go from 0 to I, like we have to check with everything, but yeah, I have to check like which one. Wait, can I see? First I need to see whether convexity holds or not. I think if I want to use CHT, I should be able to do that. We could also have something like this, right? Or like something like this. So maybe like area is greater than this. As I'm adding like more rectangles, what is happening? Let's create a graph with X. Okay, so this is X. This is my score. Let's not think about A because A is constant. Okay, so because we can separate A, right? Only thing we care about is the area. So initially area will increase. Is there any way that it will decrease? Not at all. It will never decrease. It will either be like this or something like this, right? Okay, so okay, so this is like a convex function, so we can use CHT here. Yeah. Wait, can we use penalty function? There is nothing. There is no situation here. Okay. Let's create a vector of this DP. So size of n, let's call. So initially I'm storing zeros here. Right, so if area is 0, that is going to be the score by not picking anything. Then we can start iterating. Right, we can start iterating for DP of I+1. But okay, so what is our recurrence? Recurrence is we want max of. Let's also take area out. And by the way, AI is I+1. So yeah, let me do it like IJ so that it's easier to understand. Right. X of I into Y of I. So this is going to be constant, right? We don't give a fuck about this. If we are adding this particular rectangle, this is going to be the cost. But what we have to maximize is the other part. So the other part is reducing this thing, this common stuff, which is height of this one. So height of new, which is Y of I into Y of j into X of I. Okay. So this Y of j is a slope and X of I is all right. So what do we do now? We can do query sort of a thing. So what do? We have a hull here. We can do something like hull dot query. We don't have like option. I did this. Okay. I will query. I will have to send this particular stuff here. I just have to send like X of I. What is X of I? V of I. I can't access elements like that. Is that's a tuple? Is there an easy way? I can do like X by and A maybe. So that is V of I. Now I can do this simply. So we are going to query on X. Okay. After this query, we can also remove it. Okay. Pritam, long time no see. Yeah, it's been a long time. एक महीना हो गया, I guess. So I'm learning new techniques. So this is CHT, convex hull trick, and I will also be doing aliens trick. Yeah, these are like pretty harder ones, like 2400 rated problem. This is like I believe this is a easier problem that involves CHT, but it's actually very good method because if you know this method, you can solve these problems. Yeah, I mean it's the exam season. कुछ कॉलेजेस के जल्दी हो जाते हैं, मेरे तो लेट होते हैं. कुछ कॉलेजेस के मई में ख़त्म हो जाते हैं, which I think is good. Okay. So query, and also I will be reducing whatever is this, whatever is a. Also I will have to plus y of I. So this is what? This is x into y. This is going to be my answer for this query. After answer, I will take this hull dot insert. I think I will have to give slope and intercept. So I'm going to, I'm actually, let's create everything as, let's not use integers, just for safety. Okay. Let's also use LD here. We will see. Okay. But we don't know slope. But I'm inserting like a line. But I don't know like. So this is a slope. Okay. Makes sense. So slope is negative of y of j. What am I doing? The slope is negative of y. Intercept is dp. Okay, this is also required. I think this is fine. I just have to make sure my hull is okay. Do I have a shortcut? Probably do. Is this stuff working? Not sure. So input outputs are not, I'm not even sure this code is correct or not. Do I have anything? Okay, compile. Oh, there is some error. Some error in upper bound, I believe. But what? Okay, let's do one thing. Let's do. Okay. G++ main dot cpp. Okay, so we have some compile error. It's not compiling. Issues with upper bound, I believe. Minus is fine. Wait, this is not. Let me. ये क्या है और किसका कोड है? This is CST, Convex trick. You wrote this, but upper bound expects comparator value and element and conceptually checks this. I don't understand. Where? Either write this. What is written here? Begin and x and comparator. It's literally the same thing, no? What's the difference? LDX const. Yep. Your comparator is backwards. Really? I don't. This shouldn't be a. What the fuck? Um. Okay, so it should be written like in this format. Let me just copy paste. The fuck? It worked. But what was the difference? It was the same thing. Okay. This is just so sad. What is it? Luckily, issue is parameter types. This thing passes the search value as constant reference, not necessarily. What about if I just do auto? Okay, so makes sense. So what is the parameter type? Okay. So it should be working. Should be fine now. Well, let's quickly run. Please don't ask. Oh, holy shit. Now what? I think debugging is F5 if I. Yeah. Yeah. Let's quickly do. Yeah. Okay. I want to see the value of DP. What is I of 0? I never initialized I. My bad. Wait a minute. Wait a minute. So let's initialize that as 0. And also I have to put something in hull. Wait, already have something there. But it is gonna give me some unexpected answer. No? I mean, 0 is fine here, no? Why am I starting from? This makes no sense. I should start from 0. This is 1, okay. And I should insert So we have a single rectangle. V of 0, well, I can't do it that way. So sad. So dp of 1 is going to be something. So what will I get here? I should get like, so it should be like positive. So I think okay, that is fine. I hope that works. Also, let's insert this stuff to the hull. So we need to insert dp of 0. Okay, should be fine. Let's run it again. And the thing I'm gonna watch. Okay. Oh, it was already running, my bad. How do I just stop? I still don't. Seriously. What is 3? That's the size. Makes sense. What the fuck is this? Why is this coming out to be like fucking infinity? Okay. So this query is wrong, right? Well. So what does query do? I shouldn't be getting that. If this is what is happening then. Shouldn't be less than. There is some mistake in my code, I believe. This is why. Let me check. So after all of this, what is the state of hull DQ? Can I access? What was that? It was B, right? I can definitely access it. Auto A comma B. C out A Let's take like both things. But V is like a line, so I should be... Let's go with this first. Yo, there are more elements than there are binding names. That makes sense. Yep. Okay, now that's good. Oh. Right, so we have 0 as expected, and we also have something that is too big. But there's something wrong in X calculation, I believe. Where is X? Yeah, there we go. Yeah, so it's like what I want to do here. What if slope is same? If slope is same, if slope is same, then depends on X, right? Again, if slope is same, then line will be equal. Else the line is going to... I believe we just don't give a fuck. Right? Okay. If slope is not equal to a dot second dot s failed, really, what's the reason? Assertion aborted. I mean, I'm just wondering, what if we can't... I mean, if slope is same, then what is the scenario of slope is same? I seriously have no idea. I think we can just ignore this if that's the case. So now this... Oh, but okay. Too much for me. X into line dot slope plus intercept. Let me do something. Let me do something. I'm just wasting my time right now. Issue where? Yeah, insertion is bugged. So this is bugged. But why? This should almost certainly be else break. Break this while loop. Not return. With return as soon as you find new line. So find a new line. You should new line should stay. You exit the function without inserting it. Makes sense. But wait. Also, this is dangerous because you start with and this may pop everything. Most implementations keep a sentinel and never pop it. Yeah, that makes sense. They should add. Okay. Okay, not gonna remove that. Another issue is this. So the first breakpoint should be minus and yeah, that is wait. But we don't have negative query, so I should be fine. This is intentional. Yeah, this is intentional. That's fine. Returns begin. Equal slopes aren't handled. How do I handle equal slopes? What the fuck? Let's fix it one by one. But what do you mean by break? What is the case when I don't have to add this line? If that is not true, if x is greater, why would I add a new line? Why would I add a new line? If x is greater. See, okay. I knew it. Better. Can you point out the issue in my CST code? Also use 3.1 Pro. Stupid ass. I think this is fine. Query. There is some issue with the insertion, I believe. Any answer? No. So when I'm inserting, I'm giving like some slope and some intercept. Okay. And because x is in increasing order, so slopes are decreasing. What is intercept for this? I absolutely don't have to do this. Wait, it's fine, I believe. So I have negative Y and DPO. Ah, it's okay. That is going to be answer for DP0. So, huh. Solid. Few critical bugs. The return skips insertion. Again, the same stuff. Um, it means the new line becomes optimal. Yeah. Oh, yeah. Makes sense. Makes sense. If X is greater, that means new line has become optimal. That makes sense. Yeah. Infinite loop on parallel lines. Try to insert a new line with exact same slope as your last line in your hull. Evaluates to false because there is no else block to pop the line or break the loop. But like, will I pop? So if I get like exact same line, I think I should just pop, no? And I can add this new one. But what is the guarantee like? Intercept is also in increasing order, so no, I don't. Wait. No dummy line needed if we handle empty properly. Okay. If this is not empty, so you b dot back. Will this not crash? Wait a minute. This is fine. Yeah, so for minimum hull, just like a single sign change. So that is pretty easy. Let's quickly see the mistakes here. Okay. I'm going to keep this one. Okay, should be greater than. So if slope is not equal to, if slope is equal to, then what? Okay, yeah, it depends on the intercept. As a thought. Okay. Else if a dot second dot I, even if equals, if intercept is greater, that means we are going to have like maximum over there. We're looking for maximum, right? Yeah. But if intercept is greater, then just pop back. Okay. Else we find this, we see if this is greater, we pop back, else we break. What if V is empty? If V is empty, then we push back first line. I think this is much better, I believe. So I'm going to go with this particular thing. This is much better, of course. Else I'm going to push. I don't need this. Okay. If V dot empty, then I'm going to push this way. This is going to be 0 in my case. I'm completely okay with that. And slope intercept. Fine. Okay. I hope now don't have any stupid edge case. Why is there a delay? Okay. Oh my god. Failed. Let's not. Okay. I'm going to go this way now. It's already n plus 1. DP of 0 can be 0. Segmentation fault. Let's see where. So we are here, this particular line. Everything is working right now. And then we got segmentation fault. So this is getting empty or something? What is Gemini code here? Okay, so it's checking for empty. Yeah, I'll do the same. No issue. There should be no segmentation fault. Okay, again. DPI plus 1 is fine. This is also fine. The issue must be somewhere. So we know this is not empty. So negative will always give us something, right? This should not be the issue now. There is something else causing issue. Guys, just give me like 2 minutes. I need a washroom break. I'll debug this. It doesn't. Why does. How can I see? No, like. I think it's a runtime error. So, how does the PC know where a code is? Exactly, it makes sense. But can you pinpoint the exact? Okay, let Gemini think. I'll be back. Accessing dot back. Okay, that's my mistake. Do I even know a? I don't even need it. Let's keep it here. Yeah. We get something. We get 8.3. Holy shit, minus 20. What the fuck is that? Why do we have minus 20? Minus 20. And that doesn't matter actually whether I make it of size n or n minus 1. But like, the first query should be a into x into y. Then the first query is not correct, I believe. Where is C out though? Um, what the fuck? From where I'm getting these three stuff? There is no C out in the code. I did not compile. Yeah. Getting negative 20. Holy shit. What is going to be query for DP of 0? What is DP of 0? Let me see. Compile and run. First query is 5. Should be like 16 minus 8. Right? So this is absolutely wrong. So this query should come out to be 0, right? This should give me 0. so that this is accurate. It's so what will I get in query if this is empty? I will get 0. That what the fuck is? Wait, I should get 5. 5 is correct. What about 1? I think insertion is... So this is flawed. I got -7. Well, I think I'm inserting the right... Let me check Gemini. There might be some other issues. Okay. Querying out of bounds 0 initialize. If vector is empty, you push the first line at x equals to 0. In a query function, you have this. That is not the case, so yeah. I mean, shouldn't be negative. How do I know x? Wait a minute, I'm inserting this, but where is x? So this is just a line, right? X calculation is correct or not? Should be correct. Wait a minute. Let me check what is this query. Yeah. You know what? Okay, so we have initially 0, which is correct. Then we have -15. What it should be? Am I minimizing or maximizing? So we are maximizing. Right? Better if x is less than then. Okay, I think that was the mistake. I think we can do that. Only change. Everything else is correct. Well, I just... If this is greater than pop... Wait a minute. This is for max server. Minimizing the value. 2 घंटे हो गए भाई CST, अभी तक एक क्वेश्चन सॉल्व नहीं हुआ. Let me think. So we were solving for max and for inserting y. But we are not sure about y. We are not sure about y. We were sure about x. Hold on, hold on, hold on, hold on. Something is wrong here. X is in increasing order, not y. So I think let me quickly check whether this works or not. Right. It didn't. The answer should be 9. I think I should start playing with the integers. LDs, like, right? We can sum this up -1. This stuff should be integer. No. What kind of logic is that? Let's not force this stuff. Let's use, okay. Let's also keep dp as integer because I believe the area of a rectangle, that's only going to be some integer. So okay, now we have integer values. But like slope and intercept these two integer. These will also be integer values, either negative or positive. X is also an integer. Let's case match. Let's replace them with int, right? Yeah, but here we have to use I can go with one less. Yeah, so there should be a case where I'm not gonna pick this, where I will have something like this. Okay, so this is max of DPI, comma, right. This is a condition when I'm deciding not to pick, which is fine. So this can fix all that, all those issues. I also need to track whatever is the maximum, and I need to print answer. Oh well. Just remove this. We're getting 8 as an answer, I believe. Yeah, it's same. That was not the issue. Why be having 8 as an answer rather? Uh, we only have like intercept and these two things we are using to calculate answer. Right. And I'm not sure whether they should be long or what. I'm just not sure about that. Okay. बता दूंगा. Soon. Yeah. बस ये करके I'm done. This is already hard concept. Okay, so let me just finally ask. Wait a minute. It's because of math mismatch. Narrower but taller. Wait, I'm sorting by X. Y is going to be lesser. What? So Xi is greater and Yj is greater. So Xi is greater. Okay. And Yj is greater. So Xi is smaller than Yj. This evaluates this line as Yj into Xi. Okay. Okay. Yeah. This is what I assumed. Which assumes the intersection as yi into yj for your second rectangle. This incorrect formula calculates massive penalty and drops its true potential score from. To make the equation match the correct intersection, you need to maximize j minus this. Wait, what? I don't know. This is some nonsense. Hull query, hull insertion is by as this one, which assumes the intersection is. Oh, wait. What? Oh, wait. What is X is increasing now? So what am I doing? So this is for max hull. You're going to have minimum, but if we so here it should be y, right? That to negative y. Well, even wrong. Wait, in our equation, if negative y is the query parameter, the query parameter will always be this now. Wait, y is a query parameter. Why did I choose x as a query? What? This is so stupid. Okay. But we still have wrong answer. Nothing has changed. Hmm. I believe. Okay. This cannot be 41. There is no way. But we're querying with negative y now. Okay, I know what's wrong. So if query is negative, then we should probably assign. Yeah, so this is 0. Let's go with long min. Yeah. Excuse me. Now this is correct. I hope this works now. Okay. Let me quickly wait. So the issue was this. I flipped the variable. Yeah. The fuck. What's the problem? What was the name? Rectangles, right? Yeah. This is like the hardest problem I have ever solved actually. If that works. Maybe I should take upper bound. It's running. Wait. Anything wrong here? Still running. 2400 is crazy. Okay, it's passing, it's passing. Let's go. I should probably put it somewhere so that I can use it. But like, convex hull, this thing is enough, so okay, let's quickly put it on my GitHub. Accept it. Let's go. CP templates. Let's create a new file and let's name it DP optimization. Let's name it as let's name it like CST.cpp. Okay, there we go. We have a line, we have this whole thing. I should also add something. I'll probably see whether it is for max hull or min hull. This is for min. This is not for max. But because I'm querying negative, so it just work, right? Works. In case of max, I could have also maybe. Let me do a check. Okay. So I might have chosen to do something like this. Right. Well, yeah. Okay. So the only thing I need to change is this. It's interesting, yeah. Okay, fine. So I'll do a stream tomorrow. I will solve more problems tonight of CST, about like 2-3 more problems. Then I will do a stream tomorrow and I will do like alien streak. By the way, I already know about penalty optimization, so it is going to be easier for me to understand. All right. Bye guys. Wait, should I stream game? SpaceX shit. What? चीचा यार स्ट्रीम करूं क्या गेम? कर सकता हूँ वैसे, बट मन नहीं है स्ट्रीम करने का. New stream possible. Yep. चलो पहले से I don't think I can stream anymore.